Aloha, this is Richard Halverson, and today I'm going to do, let me share my screen. Today I'm going to do Chapter 14, Quiz 14.5, and this is mostly a quiz on sets. So if we take a look at the quiz, this is what it looks like. Question 1 is you have a set of weights or a set of integers, and you want to find, you have a set of integers, and then you're given another integer, which we'll call the desired weight. And we're supposed to go through and find the integer in the set that's closest to the desired weight, and then remove that integer. So in this example here, we've got 12, 19, 6, 14, 22, and 7, and the desired weight is 18. The closest one to that would be 19. So 19 is removed, and we're just left with 12, 6, 14, 22, and 7. So that's what, and we're supposed to write a little program to accomplish that, given these names here for the variables in the set. Now, if it's possible, the desired weight can be above or below the one you ultimately pull out, so if in this case we wanted 18 and there was a 17 and a 19, there's a 17 and 19. They're both the same distance, but you would choose the 17 because it's the smaller one. Thought I was going to sneeze there. Okay. Anyway, so if you have two numbers, two potential weights that you can remove, and they're both the same distance from the desired weight, then you would choose to remove the smaller one. Okay, so that's the first quiz question. The second quiz question is very simple. It's remove the smallest element from the set. Assume the set's not empty. Okay, that's fine. And the third quiz question is remove the smallest element from the set. If the set is empty, it remains empty. In other words, you don't get an error message. Okay, so so this is in 14.5, but it's helpful to go back to 14.3 and review the sets. Okay, I'll review the section on sets. So I'm going to do that right now, real quick. All right. So you should watch this video. It's a nice video which introduces sets. The interesting thing about sets is they're similar to lists, and they're similar to tuples, except for there's some little key properties that make them different. First of all, a set, there's no duplicates inside of a set. So if the set already has a number 5 and then you try to add a number 5, it's not going to add a second number 5. It's just going to keep the number 5. Okay. And also there's no order to sets. A set 1, 2, 3, 4, 5 is exactly the same as 5, 4, 3, 2, 1, or any of those integers in any order. Okay, that's not true with tuples. It's not true with lists. They all have different properties. Okay, so the way you define a set is you use these curly braces. And so here we're defining a set that has 3 elements. And here we have and there's this set function here, which you can take any other kind of list or tuple and turn it into a set. So here we have a tuple, and it's got all the properties of a tuple, but we want to change it into a set. So it looks like this. So this is how we do it. here we're actually like generating a list. You should be familiar with this, with with what this means. So it's a list because it's in braces. It's in these square braces. That's how you define a list. Parentheses is a tuple, and a set is these curly braces. But inside here, we have a for loop. And basically, the for loop is x going from 0 to 9. And then we're taking the x and we're multiplying it by 2. So this list is x from 0 to 9, each one times 2. So it would be, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, that's the list. But we're making it a set. Okay, so anyway, so that's that. You can create a set from a string, manipulating sets. Okay, so so you can use the len function, find the length of the set, which is just the number of elements in the set. You can use the min function to find out what the smallest one is, the max one to find out what the biggest one is, and the sum to add up all of the elements in the list in the set. And so, so for example, if you have a set here and you use this add function, there's a bunch of methods that go along with this, and I think we're going to see those at the bottom here. No, never mind. You're going to see it here. List of all the methods are anyway, they're here. These are methods that you invoke them by attaching them with a period using a dot notation. Whereas these methods here right like this, this returns the number of elements, which I said was 4. The maximum of this set is 1, 2, 4, 6 would be 6. The minimum would be 1. And there's this in function, this in operator, and this is 3 in S1. And that would return false because we see this is S1 and there's no 3 in there. This is the remove method, which if you want to remove this element from this set, and this is the add, and so on. So these are these nice functions, methods that go along with that you use to manipulate sets. So you see order doesn't count, so this is true. We have supersets and subsets. They're what you'd think. And so, all right, so let's go to the quiz here. And let's go to the first question. Which is, you're given a set of weights. And so let's just pop up. I was testing out some of these methods here. But so we're given a set of weights, and let's just code this in. Let me pop this over here. Oops. Let me so I'm going to have a set of weights. What WEIGHTS weights is a set, and it's going to equal. I'm just going to start it out equaling this. Why not? You copy this. Copy. and I'm going to put it in a squiggly. All right. That, okay. And then I have a desired weight, and let's just keep the same example, desired weight. And that would be equal to 18, okay? And the desired weight is the closest element that can be less than or equal to or greater than the desired weight. Yeah, so we're supposed to remove the element that's closest to the desired weight. And that element would be called the actual weight. So it's the actual weight that we would be removing. So so we want to have a loop here that's gonna go through all of the weights and figure out which one's the closest to 18. Okay, so we're going to go through all the weights, 4 weights for W in weights. So this is going to start out with W equaling 12, 19, 6. Okay, now I need to, so I'm going to store the closest weight. Each time I come across a weight that's even closer than the one I had before, I'm going to store that value, store that weight. And so if after going through the whole set, each element in the set, I should be able to keep or remember what the closest one is. So I'm going to call that one closest. No, I'm going to call it actual weight. Actual weight. Now I want to set this equal to a default value. It doesn't matter, but I want to, I don't want to set it to something where I'm going to go through the whole list and this actual weight ends up being the closest one. So I set it wrong. So I'm just going to set it to any value, minimum value. Now I want a value. I want an element in the set, but I don't want to remove the element of the set. So I can't do weights dot remove or pop, for example. I can't do that because that removes it, and I don't want to remove it. Of course, I could do weights dot add actual weight again. That accomplishes what I want to do. I just want to set this actual weight default value to something that actually does exist, and if it ends up being the one closest, then we'll find out. But actually, another way to do this would just be to just grab the minimum value in weights, and that is not going to remove it. It's just going to tell us what it is. So I'm going to set actual weight equal to that, and then I don't need this. I hope you followed what I just did, but I need to set actual weight to be a default value, and one that's not going to mess me up. So now I'm going to go through all these weights, and I'm going to test the distance of desired weight from the element. So if the absolute value, because I want to do distance, it could be positive or negative. It could be plus or minus. It could be above the W can be above the desired weight or below it. Okay, so this is going to tell me how far the particular weight that I'm on, how far that is away from the desired weight. And if that is less than the actual actual weight, desired weight, or absolute value of actual weight, minus desired weight. If this is true, no. Yeah, yes, if this is true, if this distance, okay, this is the distance of, let's say we're going to start 7, 19, 6, 14, and if this distance is less than what we currently have as our best weight, our closest weight, then we have we have a better actual weight candidate. So we want to save that. Actual weight equals W. Just W. Okay, now we also want to test if the let's say we're looking for let's say there's a 17 here also. So I'm going to put that in there. As we go along, we're going to find this one is 6 away. 6 because this is 6 notches away. This one is only 1 notch away, so that's a good candidate. This one is 12 notches away. That's too far. This one is only 1 notch away also, and this one is the smaller of this one. So this one is below this, and so this is actually better. And so that's the case I'm trying to express right now. And what that would be is if if these two things are equal. What if these two are equal? It's only then when we want to look at the actual the value that we're looking at, in this case the 17, and right now when we're looking at 17, then actual weight is actually 19 because that was the last closest one. And so so what this is looking at now, if 17 minus 18 is equal to 19 minus 18, it is, then we would only want to capture this if the new one is smaller than the last one. So we want to do and W is less than actual weight. If that's true, then we want to say actual weight. We also want actual weight to W. Now we could actually combine these two if statements or these two clauses, but I don't buy it. This is fine. So that's it, and we're going to go all the way through them. There's no order, so we don't know which ones we're getting when. But when we're done, our actual weight is going to be the closest one. So I'm just going to print actual weight. Okay. So I'm going to run this. And so let me do, it's Python. It's how I call mine on my computer here. And the name of this file it's on the desktop, test.py. And it tells me 17. Okay, so this isn't, I'm going to say, I'm going to say print weights. Then I'm going to say desired weight equals desired weight. Okay, just so I know what's going on, and then it's going to print out the actual weight. I'm going to do this. I'm going to say print set actual weight equals W. I can watch what's going on here. Okay, so let's run this and see what this looks like. Oh, it's probably because 17 is closer than 19. It probably came across, it came across 17 first. That's the problem. So of course, and so it hit the first one right off, even though we defined it this way. All right, I'm gonna do, I'm gonna do 20, well, 19 is away from 21. Oh, I'm going to do 19, 20. Well, let me just try another number here. Oh no, let me try 20, 16. No, let me try 10. So first I guess it starts looking at 17, and then it hits 7. Here, I should print actual weight equals actual weight, and then print W equals W. Okay, so it starts out where it sets actual weight default, it sets it to 6. Why? Because 6 is the minimum of all that. So that's what it sets as a default. And then the first one it looks at is 17, which is this. And then it's not going to change it's not going to change actual weight because 6 is closer to 10 than 17. Okay, then it's going to look at 19, and 6 is closer to 10 than 19. And then it's going to look at 6, and 6 is 6 is the same as 6. So neither of these cases is true. So it remains 6, actual weight remains 6, and we did not execute something like that. Then the next thing we try is 7, and 7 is closer to 10 than 6. So we set actual weight equal to 7. And then we try 22, and 22 is not closer than 7. We try 12, 12 is not closer to 7. 12 is closer to 7, is closer to 10 than 7. 12 is only 2 away from 10. And the 7 is 3 away from 10. So that's why this thing gets set. Now our actual weight is 12. And then we try 14, and 12 still has it. And so we print out 12 at the end. Okay, so anyway, so that looks like this will work. And it's going to be something like you copy this in there or something. Or you probably don't have any of the, get rid of all the print statements. And you should be able to copy that in there. You would get rid of this and get rid of the print statements. I think that'll do it. So anyway, that's up to you. All right, what's next? All right, remove the smallest element from the set S. You know, these are just, so let me, here we have a set S, and we want to remove the smallest element. Well, you know, smallest equals this, and then we just have to remove it. You know, we can do this. You know, I mean, just that'll work. So anyway, that's the trick there. And number 3 here is remove the smallest element from the set. If the set is empty, it remains empty. Well, I would just make an if statement, and you test if the length of the set is greater than 0. If the length of the set is greater than 0, then you can go ahead and do like we did in the last question. But if the length of the set is 0, then you don't do anything. Okay, so you have an if statement, and so I think that will solve that problem. All right, I hope that helps. Thanks for watching.